All right, guys. In the next few videos, we're just going to be going over the new practice SOL that I put into Schoology. So it's the 2026 practice SOL. The notes I'm going to be going off of are posted as well. So this has right here all the answers. Just understand, like when you do take this SOL, once you this practice one, once you submit, you'll see what all the correct answers are. So um, you want to wait and try this, when you think you're prepared, and then give it a try. And then if you don't do so well, make sure you look at the answers, maybe watch these videos, uh, and I'll go over every single one of these questions, okay, and how to answer them, okay. But before that, I just want to remind you of a couple things. So if you haven't done this yet, make sure you go to the TestNav website. So you just follow this link, okay, and that'll take you to the SOL website. And you want to click on science, click on chemistry, and you want to click on the chemistry 2018. That's the newer version, and that's the one that is starting this year for 2026. So you want to make sure you've done that. You do want to look at these practice items as well, so make sure you do that. But you want to get in here just to see what the SOL is going to look like. It's not going to look exactly like the Schoology assessment, so you want to give this a shot and go through it and really get used to the tools, right? Get used to using the Desmos calculator and not a handheld calculator, right? So make sure you can put Avogadro's number in here and all that stuff. All right, and then understand you're not going to get a paper periodic table. You need to open the exhibits here when you're taking the SOL, and you need to click on the element, and all the information pops up into the box. Remember that you have access to this. You don't need the periodic table for every question, but you will need to refer it to multiple times. So make sure you do that, okay? So get used to the way the SOL is going to look like, okay? But the types of questions, those practice Schoology SOLs that I've posted, are good practice for the type of content you're going to see and the type of question you're going to see. But you really want to get used to the style that it's going to show up in TestNav, so make sure you check that out, okay? And in this video, I'm hoping to get to questions. If we go back to the practice SOL, I'm hoping to get through practice questions 1 through 10. But understand why this is probably a really good practice SOL for you to take. If you're not going to do all of the practice, this is the one to make sure you do. Because as you start it, I've kind of broken down how I made this specific test, and I broke it down according to the SOL blueprint that the Virginia Department of Education puts out. So let's go ahead and check that out, and just so you can kind of see where I'm getting the types of questions that I'm putting on this practice SOL. All right. So if we look at, this is from the state of Virginia, right? It tells you that when you take the SOL, you're going to have 55 questions, but 10 of those questions are not graded. They're called field test questions, but you don't know which 10 they are. So you want to treat every question as if it's graded, okay? So you have 55 questions to answer, okay? On this practice one that we're about to go through, I only have 45, but I based those 45 questions based on this blueprint that the state has published, right? So you got 45 questions. These are the 45 types of questions that you will be graded on for the SOL. 9 of them come from this category, atomic structure and periodic relationships. 11 come from chemical formulas and reactions. 13 questions come from molar relationships, and 12 questions come from phases of matter, right, and kinetic molecular theory, okay? So, right, if we can understand how to do these types of questions and this many of those types of questions, we should be in good shape for the 45 questions that will be graded on for the SOL. And hopefully you do your best on the field test questions. Again, you won't know if it's a field test question. Maybe if it's something totally foreign to you that you've never seen before in chemistry class, that might be a field test question, but a lot of it's going to be stuff that you have seen before. So make sure you try your best on it, right? And the other thing to understand is on this practice SOL, I think I have more than, all right. So, you have 55 questions, and they tell you 15% are going to be what they call TEI questions. Those are, they call technology enhanced items. Those are just non-multiple choice. So the bulk of your test, I would say, 35 to 45 of the questions you're going to see are going to be multiple choice questions, just regular. There's one correct answer. And then 15% of the questions, so about 10 questions, are going to be technology enhanced questions. And that could be multiple choice. That's multiple correct answers, and you have to select all the correct answers, or it could be click and drag, like click and drag to balance a chemical equation, or different things. Or it could be, a free response where you have to type in your answer to a calculation or something like that. But the majority is just going to be straight up multiple choice. On the practice SOL, I'm covering this exact content with these numbers of questions, but I think I might have more non-multiple choice questions just so that we can review more concepts. Okay, but you're going to see mostly multiple choice when you take the SOL. Okay, all right. So again, if we go back to this practice SOL, I have it set so that it's not going to be in random order. Understand you won't get all the atomic structure questions, and then all the balancing questions, and then all the periodic trend questions in a row. They'll be random, okay? But in order for this to be a nice review of all the different concepts, we kind of have them all in a row here. So the first 10 or so questions are going to be the atomic structure. And if you're looking for places to review, right, atomic structure and periodic relationships, that's our units 2 and 3, okay, at West Springfield High School. All right, chemical formulas and reaction, that's going to be units 4, 5, and 6, okay, our units. So if you're looking for things to review for this specific category, right, these are the units to go back and review. Molar relationships, we start that in unit 1, and then we've been revisiting in unit 5, unit 6, also unit 7. So, molar relationships been one that we've been discussing all year. But the phases of matter in KMT, right? We talk about the states of matter, endothermic, exothermic, phase diagrams, heating curves, and a little bit of kinetic molecular theory back in unit 2. And now we're wrapping it up in unit 7, where we're adding the gas laws to it, and heat calculations and that kind of thing. So make sure you're staying current in your chemistry class, because these concepts we're revisiting from unit 2, and we're adding to them, and we're not getting a lot of practice right before the SOL. So make sure you're doing that stuff so you know how to answer these questions on May 20th. Okay, so we're going to go ahead and start and just get through some of the questions here. Okay. All right. So here we got an average atomic mass question, right? They give us the isotopes. So we have an isotope that's has a mass of 35, and we have an isotope that has a mass of 37. They tell us the average atomic mass. Remember, we could look that up if they didn't give it to us, right? We go to the periodic table. Let me get the periodic table out. We find chlorine, 35.45, right? So we have our periodic table. So they didn't need to give us this. But they're just asking, based on the fact that these are the 2 natural occurring isotopes, and this is the average atomic mass, what can we conclude? Okay, so remember, isotopes just mean different mass, but same atom, and that means they have the same number of protons, but a different number of neutrons. So how are they different? Well, chlorine 37 has 2 more neutrons than chlorine 35. But the reason why the average atomic mass is closer to 35 than it is to 37 is because 35 must be more abundant. So that's what we're kind of looking for. And it's this choice. Chlorine 35 has a greater natural abundance compared to chlorine 37. Okay. Right. I got some notes here. Right. So understand how average atomic mass works. It's a weighted average, kind of like how your chemistry grade is come up with at the end of the year. Your grade book is, 85%, and your final exam and IRP is worth 15%. It's kind of the same idea. If I have 2 isotopes and they were both 50-50, 50% abundant, then it would just be the average of these two numbers. It would be 36. So the closer this number is, 35.45, is to one of these, that's going to be your more abundant one, right? 36 is right in the middle, 50-50. If I'm closer to 35, that means 35 is more abundant, right? And if I was closer to 37, then 37 is more abundant, okay? Remember, you can't be chlorine and have a different number of protons. So, right, when you see a question like that, or an answer choice like that, you know it's wrong. You know, cross it out, okay? All right, so we go back to the test. I'm gonna have to move myself up here. All right, here we go. All right, so here we have a nuclear equation, and we just have to find the particle that's going to balance this, right? If we want to review, right, remember gamma radiation is just high energy light, so it has a massive zero and atomic number 0. So it's never going to be gamma radiation that's going to go in here and balance an equation, okay? This is a positron, if you remember that. This is an alpha particle. If you remember that, this is a beta particle or an electron, right? So positron, positive charge, electron here, negative charge. And it's really just like what numbers would go here, and then find those numbers here. Remember, this is an equal sign. So if we go to my notes here, right? So we got basically, we're saying 236 equals a number here plus 232, right? So 236 equals x plus 232. So that number equals 4. And then the bottom number here, we got 92 equals, you know, our unknown plus 90, right? So 92 equals y plus 90, so y equals 2. So the number's 2, or sorry, the mass number's 4, for the particle, the atomic number's 2, and the symbol for atomic number 2 is helium, so that's D, an alpha particle, okay? All right, and if they ask what type of reaction this would be fission, right? It's a bigger nucleus breaking up into smaller nuclei, that would be fission. If it was if it was the reverse, like two things smashing together to form a bigger nucleus, that would be fusion, right? Maybe they ask about that. All right, go to the next one. All right, so here we got a drag and drop, okay? And it's about the periodic trends. The main trends you want to be familiar with are ionization energy, electronegativity, shielding effect, and radius. And if you remember, radius is the snowman. And then if you remember, electronegativity and ionization energy are opposite the snowman, right? So if we look at our periodic table, right, I know as I go down into the left, like as I start from helium and go down towards francium over here, radius increases, right? So radius gets bigger as you go down, but if you knock the snowman over, it gets smaller as you go left to right. So radius decreases going up to helium, it increases going down to francium. And if you remember that, and just remember ionization energy and electronegativity are opposite that trend. So ionization energy increases up to helium, electronegativity increases up to fluorine. Remember, we don't include the noble gases for electronegativity, okay? And then shielding effect increases as you go down, but stays the same, you know, going across the periodic table. So those are the main ones, you know, you want to be aware for the SOL. Let's see what I wrote. Oh, if you want to pause the video, I showed the same equation from the nuclear reaction if it was the same atom, uranium-236, if it underwent beta decay versus, you know, positron decay, okay? Just kind of how that would adjust the equations. And remember, these symbols are based on the number that's calculated here, okay? Atomic number, you go to your periodic table and you find the chemical symbol, all right? So again, for the trends, okay? So back to the test. Sorry, got a lot of tabs going. All right, so which trend increases going down? Well, we know that's radius, and it decreases going left to right, right? That's snowman, so that's atomic radius. So which trends increase going across but decrease going down? So opposite the radius trend, that's going to be ionization energy, electronegativity, okay? Now there's a third one here, and we'll talk about it, but then which trend increases going down but stays relatively the same, that's shielding effect. So if they ask what has the greatest shielding, you're just further down on the periodic table. That's what you're looking for. Okay. Now, if we think about the periodic table, another trend is metallic character versus non-metallic character. And again, if we go back to the periodic table, it probably won't ask about metallic character or non-metallic character on the SOL, but maybe. Remember, metals lose electrons, so the lower ionization energy is the most metallic. So you become more metallic as you go down into the left, and that means you could become more metallic as you go up into the right. So non-metallic character increases going up to fluorine, right? Fluorine is the best non-metal, whereas francium is the best metal. So if we go back to the test, it would be non-metallic character that has the same trend as electronegativity. Okay. All right. We go to the next one. All right. So we got an electron configuration, and you're going to get a couple electron configuration questions. You know, and what you should just do is, are you doing it for an element that's neutral, or is it in a compound where it's an ion, right? So sulfur, we should know, is going to be this one: 1s2, 2s2, 2p6, 3s2, 3p4. That is sulfur. But if they had asked for sulfur in a compound like sodium sulfide or something, that would be S2 minus. That would mean it gained 2 electrons, and then it would have that electron configuration. It would be the same electron configuration as argon, right? So if they ask for an element, just an element with no charge, right? But even if they ask for sulfur, but it's in a compound, it's not neutral. Remember, it has an oxidation state, not zero. So if they ask for an electron configuration of something in a compound, it's going to be the same as a noble gas configuration, right? If we go to our periodic table, right, this is sulfur. If they ask for it, right, this is the P block, 1, 2, 3, 4. So it's going to end in 3p4, right? But if they ask for sulfur in a compound, or S2 minus, that's going to be argon's electron configuration, sulfur's closest noble gas. So all you have to do, if they ask for an element and it's in a compound, find the element on the periodic table and then go to its closest noble gas and write that electron configuration instead. All right. But if it's just the element, then for sulfur, it's going to be 3p4. But if it's S2 minus, if it's sulfide, it's 3p6. If they ask for K, it's going to end in 4s1. Its electron configuration is going to be 4s1. But if it asks for K in a compound, it's going to be K1 plus. It means it lost an electron. So K1 plus, K potassium in a compound, is going to be argon's configuration, because what's potassium's closest noble gas? It's argon, right? So K1 plus and S2 minus have the same electron configuration. They're isoelectronic with each other. That just means it has the same number of electrons. If you have the same number of electrons, you have the same electron configuration. So it's argon's configuration, okay? So in this question, it's just sulfur, not in a compound, so it's just regular sulfur. It's this electron configuration. But again, if it was in a compound, sulfur's closest noble gas is argon, so it would be argon's electron configuration. Okay, let's see if I wrote anything down, right? So here are the trends, right? Radius, snowman, it increases going down, but if you tipped it over, it decreases going across. You know that these trends are opposite this trend. So if radius decreases this way, ionization energy increases this way, okay? And then again, sulfur in an element is this configuration. It ends in 3p4. But if it was sulfur in a compound, you know, it could be sodium sulfide, it could be magnesium sulfide, it doesn't matter. In that compound, it's not S, it's S2 minus. That means 2 more electrons. So if this is its normal electron configuration and at 3p4, if you add 2 more, remember, a p sublevel can go up to 6. So those 2 electrons go there. So it goes from 3p4 to 3p6, which is, again, isoelectronic with argon. It just means same electron configuration. Okay. So for this one, it was this answer. Okay. But remember, it's going to be in a compound as well. So watch out. Okay. So here we have a particle. They give us isotope notation. Remember, this number is the mass number, protons plus neutrons. This is the atomic number. It's always protons. This is the charge. If there was no number written here, that means it would be neutral, okay? Remember, 8 protons, 8 electrons if you're neutral, right? Whatever number of protons you have, that's how many electrons you start with. 2 minus means I gain 2 more electrons, so that's going to change to 10, right? 2 minus means I have 2 more negative charges than positive charges. I have to have 8 positive charges because that's what atomic number means. So if I have an overall -2 charge, that means I have 2 more negative charges. So I have 2 more electrons than protons. If this said it said 2 plus, I would take away 2 protons and it would be 6 electrons, right? I would take away two electrons and have 6 electrons. Remember, 8 atomic number, that's the proton number. That's locked in. That can't change. So if this said 2 plus, it would be 6 electrons. If this is 2 minus, it is 10 electrons. Okay, how do you find neutrons? Mass number minus protons, right? 17 minus 8, 9. Okay, if this was 16, then it would be 8, right? If this was a mass number of 16 and this was neutral, it'd be all the same number, right? Okay, so but the answer would be 8 for the protons, 9 for the neutrons, and for this one, 10 electrons. Okay, let's see if we have any notes on this. Yep, okay, so remember, mass number is always the top number. Atomic number is the one on the periodic table, right? Remember, this number is not on the periodic table, right? If we go to oxygen, if I can remember where I put my periodic table, if I go to oxygen, right, there's no 17 on there, right? 8, 16, right? This is average atomic mass. This is not mass number. It's different things, right? So whatever we were looking at in this problem, whatever we were looking at in this problem, it wasn't an oxygen atom that weighed 16. It was an oxygen isotope that weighs 17, okay? All right, J.J. Thomson, you got to remember cathode ray, electron, plum pudding model. So I just see J.J. Thomson, I'm clicking plum pudding. There you go, right? If I see J.J. Thomson, I'm thinking 3 things. I'm thinking cathode ray tube experiment. I'm thinking electron discovery. I'm thinking incorrect plum pudding model for an atom, okay? They'll ask about J.J. Thomson, or maybe they'll ask about Rutherford, or maybe they'll ask about Dalton's atomic theory, right? So when it comes to JJ, right, you want to think cathode ray tube, electron discover the electron plum pudding experiment. When it comes to Rutherford, you're thinking gold foil experiment. That's when he used the alpha particles. He fired them through gold foil. He discovered the atom is mostly empty space, right? That's what he gets credit for. But basically, he gets credit for how small and massive and positively charged the nucleus is and how small it is compared to the rest of the atom, right? That was gold foil, Rutherford, okay? Nucleus. And then Dalton had his atomic theory where he was kind of off. He thought, he didn't know about isotopes. He thought all carbon atoms were identical to every carbon atom. We know, carbon can be carbon with a mass of 12, carbon with a mass of 13, carbon with a mass of 14, right? So, but, J.J. Thomson, cathode ray, electron, Rutherford, gold foil, atoms mostly empty space, the nucleus is small and dense and positively charged, right? That's what we are thinking when it comes to our history and, scientists and stuff, all right? So we move to the next one, try to get to number 10 for this video, and then we'll move on to more questions in the next video, all right? So electron transitions, right? Remember flame test. Remember, an electron in its normal electron configuration, that's called the ground state. If an electron absorbs energy, the electron can jump to another energy level, but going from a lower energy level to a higher energy level, that doesn't release the light, that absorbs it. It's when it falls back down from a high energy level to a lower energy level, that's when it releases the light. That's when it releases the photon, right? So which of these energy level transitions would result in a release of a photon, it would have to be from a high energy level to a low energy level, right? It has to absorb light or absorb energy to go from a low energy level to a high energy level, okay? So we're just looking for the one that we're going down. So energy level 4 to energy level 2, okay? That would release a photon, all right? So remember, right? Here's the electron. It's in its lowest energy level, n equals 1, closest to the nucleus. If it absorbs energy, it can jump to a higher energy level. But that's not what releases the light. The electron here has high energy and it wants to get down to a lower energy level. So it has to lose energy, and it does so by releasing light. So energy level 2 to 1 releases a photon. Energy level 1 to 2, would absorb a photon. Okay, so it releases the light, and that's what you see in the flame test as it's falling back down to the ground state, back to a lower energy level. Okay, all right, go to the next one. All right, which of these metallic atoms would have the smallest radius? So this is just further down into the left is the largest radius, furthest up into the right would be the smallest radius, right? So we're looking at potassium, calcium, magnesium, sodium, right? You're going to want to call up your periodic table, right? So you're going to have to click that exhibits button, pop up your periodic table. So we're talking about these metals here. So of these 4, it increases this way, it decreases this way. So we know magnesium's the smallest, potassium would be the largest, right? It would go probably magnesium, then sodium, then calcium, then potassium, all right? But you really wouldn't know sodium versus calcium based on the trend, right? So of these 4 metals, potassium would be the biggest and magnesium would be the smallest in terms of how much space they occupy, what their radius is. Okay, so if we go here, right, it's going to be magnesium, right? This is the way radius increases, so it decreases going the opposite way, okay? And so we would check magnesium, and we're moving on, okay? Now be careful with this. Valence electrons, you know this. You look at your periodic table, right? All right, so remember, looking at your periodic table, right? Forget about the transition elements. If you're asked about valence electrons, it's probably going to be from S block or the P block. So remember, 1 valence electron, 2 valence electrons, 3 valence electrons, 4 valence electrons, 5 valence electrons, 6 valence electrons, 7 valence electrons. All the noble gases have 8 valence electrons except for helium, which only has 2, right? That's what you got to remember, right? So they asked about carbon. Carbon's in group 4A, so it has 4 valence electrons, period. That's it, right? Don't get distracted by electron configuration, because that's when you can get confused, right? A lot of students are going to see 2 here and think the answer is 2, right? Remember, valence electrons are highest overall energy level, not sublevel. S and P are sublevels, right? Its highest energy level is energy level 2. That's what these numbers represent. And the exponents are how many electrons. So it has 2 plus 2, so it has 4 electrons in energy level 2, which is its valence shell. So it has 4 valence electrons. But you already knew that because carbon is in this group, so it has 4. If they asked about germanium, it's 4. If they asked about lead, it's 4. Anything in this group is 4. Anything in this group is 5, right? Easy, right? You hope you get a question like that on the SOL, because that's easy money, right? Don't get confused that they gave you the electron configuration, right? You can find it from the electron configuration. Just remember, it's always the highest S and P sublevels that have electrons in it that you count, the electrons, for the valence shell. S and P, not just P, okay? All right. So the last one for this video, we'll do number 10, okay? So they give us a chemical formula of ammonium phosphate, and they say how many total atoms are in one formula of the compound. So remember, a formula unit is basically the word molecule, particle of an ionic compound. And so since this is a salt, an ionic compound, we don't say molecule, we say formula unit, okay? So it's just saying in one of these, how many total atoms are there? So we got to interpret this formula. So we got to be able to understand that there's 3 times 1 nitrogen. There's 3 times 4 hydrogens. There's 1 phosphorus, and there's 3 oxygens. And then we just have to add that all up, right? So, sorry, if you look at the notes, right? Valence electrons, right? So here, okay. So we got 3 nitrogens, right? 3 times 1, right? The 3 has to be distributed through the parentheses. We have 3 times 4, so that's 12 H's. We have 1 P, 1 phosphorus, and we have 3 O's, right? So it's just 3 plus 12 plus 1 plus 3, and that comes out to be 19, okay? Right? And if you need to, right, it's not a time test. You have plenty of time. You got all day if you need it, right? And so if you need to use a calculator, calculate it, right? All right. So that's part 1, questions 1 through 10 and kind of the structure. We'll pick it up for questions 11 through, let's say, 25-ish, maybe 11 through 30 for the next video. All right. But we're just going to jump right into the practice because we've already explained what this practice SOL looks like and why it looks like it, right? So remember, get into TestNav, make sure you're looking at the way the questions will look on your computer screen through TestNav as well. All right. Okay. Good luck. Pass advance, right?